Hello everyone, I'm Kevin Nyhuis, and this research that I'm about to present was done with Dr. Joanna Kinsey in affiliation with Quinnipiac University. The focus of this research was on the biodegradation of dissolved organic matter in the Quinnipiac River estuary. Dissolved organic matter, or DOM, plays many important roles in the biogeochemical cycling of estuaries, and the knowledge of interactions and degradation of DOM in estuaries is still not completely understood. So in this research, we took water samples from the river at 4 different locations. The locations were Lighthouse Point Park and East Shore Park in New Haven, Target in North Haven, and the Hackinson Fishway in Wallingford. The samples were filtered by vacuum filtration and then inoculated with 1% by volume of the original unfiltered samples. The inoculated samples were then filtered again and analyzed for absorbance and fluorescence at select time points over 55 days. The target and fishway samples were additionally analyzed for their non-purgeable organic carbon, or NPOC, and total nitrogen concentrations. Using absorbance and fluorescence spectroscopy, we're able to create excitation emission matrices, or EEMs, seen in Figure 1. The location of fluorescence intensity on the EEMs helps to classify the type of organic matter present in the sample. The peaks labeled on the EEMs in Figure 1 are explained in Table 2 here. In order to gain a better picture of the changes in composition of DOM, the fluorescence values can be graphed as a bar graph shown in Figures 3 and 4, which represent the fishway and target samples respectively. When looking at these bar graphs, we see a general decrease in the B and T peaks, which represent tyrosine and tryptophan-like organic matter. There also appears to be an increase in HIX, which is the humidification index, or HIX, and corresponds to the amount of humic-like dissolved organic matter in the sample. The fourth value is BIX, or biological index, or BIX, which is the measure of the biological activity in the sample. We used one-way analysis of variance tests on these values and found significant increases in the humidification in Fishway and Lighthouse Point Park. There were also significant decreases in protein-like organic matter in all locations. This suggests that microorganisms consume the smaller protein-like organic matter and may convert this organic matter into larger humified molecules in the process. Figure 5 shows our results for non-purgeable organic carbon and total nitrogen concentrations for Fishway and Target. There appears to be a slight decrease in NPOC concentration, which could be from the microorganisms converting organic matter that they consume into carbon dioxide and respiring it. And we don't see much change in the total nitrogen concentration over 55 days. However, neither of these changes were considered to be significant enough to confidently draw conclusions from using the one-way analysis of variance test. The dissolved organic matter in the Quinnipiac River estuary will eventually be either converted to CO2 or enter the Long Island Sound. This research is part of a much larger project to understand the interactions and processes of organic matter in the Quinnipiac River estuary, and there's still a lot more further analysis that needs to be done on these samples, as well as many other samples that were collected in order to put together a full picture of the carbon cycling in the Quinnipiac River. With that, I want to thank everyone for listening, and I would also like to thank Dr. Joanna Kinsey, Dr. John Greenleaf, as well as Quinnipiac University for their assistance in this research. And I hope that everyone is staying safe and healthy at home. Thank you.